Hi, this is Bob Fossil. In this video I'll be attempting to remove the protection from Spectrum original tape on my Spectrum Plus 2. I'll be trying to remove the Speedlock protection on the Ocean game Whizball, I think from 1987. So three things to solve before we could attempt this. First issue was the screen capture. If you've seen my early videos, I'd got a rather rubbish screen capture solution, so I've improved that by spending literally tens of pounds on China's finest SCART to HDMI conversion technology, so hopefully that's now doing a better job. It seems that the picture's a bit more stable, and remember in the previous video when I loaded anything with a turbo loader in, the border went haywire and the picture went on, it just lost the picture, so I think that's been sorted. So that's how we're going to get the image in. I've got that running into SCART to HDMI, then I've got a HDMI to USB 3 into my computer. Hopefully that's going to pick up everything. Second problem is I don't actually have a Whizball original tape. Let's say that's not strictly true. I think at my mum's house somewhere there's a Magnificent 7 collection, which I did actually have this as an original tape, but that's nearly 40 years old now, so I can't imagine that's in a decent state. So to do the work of the tape, on shamelessly stealing a solution I saw on streamer DJ Hoffman's Amiga cracking stream. He was using one of those cassette adapters that you can get for a car stereo that basically is like a pretend tape that you can, it's got like a 3.5 jack, audio jack wired into it. So I'm going to use my PC with Audacity to play a TZX file of Whizball, which I've converted to a WAV file, and that was an absolute faff because I'm using Linux and there doesn't seem to be any nice way of doing that. You've got GUI utilities in Windows, so I have to mess around with command prompts. I couldn't get it to work properly. I tried various volumes and all sorts of things, and so I eventually compiled a different TZX or WAV file program, and I think that's working. So we've got a tape, so that's going to be the Whizball tape. But then third issue is I've not got any multiface or soft ROM or plus D hacker or anything like that. I'm going to try and crack the Speedlock with just my divMMC Future. Now you're probably saying to yourself, Bob, the only way you're going to be able to do that is if you've written some sort of NMI based debugging system with a sort of disassembler and all sorts of stuff, because you're not going to get very far with just using the standard NMI. And spoiler alert, yes, you're right, that's what I've had to do. I've past few months on and off, brief interruption to try and write an unplayable snake based Pong game. I've been working on this, so we've now got this new, you press the NMI button, now you get these options of monitor, browser, which launches my long file name browser and exits. So if you press monitor, we now got this sort of basically it's like kind of action replay kind of thing for, that's where the blue and white comes from of the Amiga, but it basically for the ZX Spectrum. So that's your Z80 registers. You've got PC, stack pointer, you've got the status flags, you've got the shadow registers with the quotes after them. So yeah, so that's what we're going to use to try and break Speedlock. So another spoiler alert, it's a lot easier to break the protection on Speedlock than it is to actually try and write one of those magazine type-in pokes where you have to try and actually deactivate the protection. The way we're going to do it, we avoid a lot of those problems because we just basically can load past the code and let the decryptors run, and we can just break in and go from there. But we're getting slightly ahead of ourselves, so I press X to go out there, type in load dot dot. So if I press play on my pretend cassette and then go into Audacity, says with a slight air of surprisement in his voice. There we go. You know, I was saying about the volume. I'm having trouble with the thing. We're going to have that now, aren't we? So let's try that again. Hooray! So this version of Speedlock is possibly the longest version of Speedlock before it actually gets to load in the game. The Speedlocks before, and there we go. Here we go. So this was, just tried this and it was working, and now it's not. So that's there. Try the volume and give it another go. So I need to push back from there. As I was saying, this is possibly the longest version of Speedlock. Say the versions before and after this were just like the one short basic and then the shortest block of machine code, and then they get into loading the game. But this one's, I think it's a peak Speedlock. It's got a ton of decryption code, and it's loading all this stuff in now, and then there's two variants of this version of Speedlock, where there's one that does like a like a stuck loading pause, and this one, which is basically sounds like two robots having an argument. Just lots of bleeps and bloops. And weirdly, the TZX seems to end the audio before the actual decryption sequence is finished. So, will this load? No. So I'm stopping tape after loading the first block. So if I now go into the monitor, as I said before, because I'll just stop the tape because that's making a noise. As I said before, because we're actually just trying to crack this, we don't actually need to do any of the hard stuff of actually going through all the decryptions and all that sort of stuff. We can just basically break in after the decryption has run. So we've now loaded in that first short turbo block, and the way Speedlock works is that turbo block actually tells the loader where to load the various bits of the game, because although Speedlock sounds like it's one continuous long turbo block, it's actually lots of bits of code, so it can load to different places. It can also load over itself, so it can be quite tricky if you're not aware of that, because when I first encountered it in many moons ago, I was trying to treat it like a one long turbo block, and it's not. And it can you can try and make modifications to the loader, and then the loader gets overloaded with code from the tape, so it's all a bit, yeah, it's all a bit tricksy. So the thing we need to find is where the Speedlock table is, and that's basically tells the loader where everything is. And in this version of Speedlock, if we look at the IY value, which is 65374, the M command just does like a standard memory dump, and we can see there it's basically the first one, the 8000, that's the hex loading address, and then the 2FF is the bytes to load. So I think that's the attributes for the loading screen, and then the 10 after it that's the 1 to 8K RAM bank. So if this was like the 1 to 8K, if this was doing like a long 1 to 8K load, those would be potentially be loaded. It could be like 11 or the different RAM bank values, but because this is just a sort of standard, I think that's to work on 48K as well. All those values are going to be 10. And then if we see from 65414, we've just got a row of zeros, and that indicates that that's the end of the table. So it'd be really nice if we could find out what that table was doing. But before we do that, I'm going to take a snapshot, so just make sure I'm in the right directory. So yeah, I've created myself a little folder, so that if I do save SA, save all, and then speed. So save all it gives you the ability to save a snapshot file from the current state of where you are in the monitor. So hopefully, if I do that, I have got the world's slowest SD card in here, so it will take a bit. So I've also added in just some dots, some like a progress thing here to actually show you this. It's not sort of locked up. So eventually we should get an OK. But marginally faster than reloading the Speedlock block. So now we want to get back to basic, because we want to find out what this table actually, the contents are, so we can see where the game is being loaded to. A lot of the information I'm using to do this deep protection of Speedlock comes from the How to Hack articles that were published in Your Sinclair by their resident hacking expert Jon North, and he dedicated a couple of those to articles to Speedlock, and he actually published a little basic program which you can see in the list in there, which I've called table.baz, which will show the address of, or it'll decode the addresses in the Speedlock value, but at the moment we're stuck in the Speedlock code, so we need to sort of break back to basic but preserve the memory. So I've added in, there's a SR soft reset command, and you can give it an address. So that basically will do a soft reset, but it will preserve the memory from 32768 onwards, and as I say, the Speedlock's quite high in memory, so that should give us enough to play. So if I exit out, we're back in basic, and then if I do load star table, I've previously told it what the address was, so if you look in there, that 65374 is the address that we got from the IY value, but because the memory is preserved, we can actually put that into some human decodable number. So yes, that's first block is the attributes, and it's loading a chunk of memory, and then there's some weird loads there. I think that's where it's loading bits into the Speedlock. The address is in the 60,000s, and then another block to, and then finally that last block to 2483. So we know that from memory from 2483 onwards is going to be used by the game, but that gives us a bit of space for the basic loader. So now we know where we're working with the game. So if we go, press the button, go to monitor. If I do, so if I load back in my speed snap, So when that's loaded in the snapshot that we saved earlier, and as you can see, when it loads it in, it will give you the registers from the snapshot file, and we're back in Speedlock at 64787. So if I exit from that, I write the right bit in the tape. Fingers crossed this actually loads. We'll get a good indication whether it's going to load or not by if the loading screen looks like it's not messed up and I've forgotten to do something. So I'm going to have to stop the tape there, which is not going to end well. So if I load all my speed.snap. What I needed to do was in the articles, that the how to hack articles, it talks about this thing called the standard Speedlock patch, which is an address that you can search, some opcodes that you search for, which you change the address to, and then that lets you call a bit of your own arbitrary code before the Speedlock starts the game. So so the find that looks for these opcodes ED53, which is found at 650965094. So this is the Speedlock patch. This is the thing we need to patch. So, but the address is actually above it. So if we do 65090, so that load DE, 65349, that's the address that'll get run when the game loads, but we need to change that to, we somehow need to change it to call our monitor, and we can do that by calling the NMI code, which is the function, which is what happens when you press the button. So we need to change that load DE 65349 to load DE, 102. And we can do that by doing 65092. P is the poke command, and you can do multiple pokes by doing comma separations. And then if we do disassemble 65090, we're now going to go, so we've told it to, that will force the Speedlock to jump into address 102, which will fire off the NMI. So, got the, start the tape up, hope everything's going to work, and second time lucky. How is this going to work? Okay, so the loading screen looks okay. So that's an easy way to tell on a turbo loader, is it's going to work on a Spectrum, is how well, whether there's like you've got flashing colours, or whether there's the attributes are all a bit wonky. Turn the volume down a bit on the loading. It's a nice loading screen actually. Yeah, it's a Magnificent 7. It was a not bad compilation. So you got Whizball, Arkanoid, Cobra, Head Over Heels, Great Escape, Frankie Goes to Hollywood, some other ones as well. short circuit and something else. So yeah, I say you got quite a lot of bang for your buck. I think also the Christmas I got that. I also got I got a plus D disc interface from ZX Spectrum, and that was a game changer. That was. So yeah, this tape count is loading in 2 minutes. It's plus D with the disk drive and the snapshot, which would basically save the memory to disk. That would load. You could load a game, about 48k game, in 4 or 5 seconds. On this 2 minutes and waiting for bleeps and bloops and all that sort of stuff, it was straight in. So 1 to 8k game loaded in 10 seconds. So you're getting in the moment of truth now, whether actually the game will work or whether it's just going to sort of crash back to a black screen or the Sinclair or the Amstrad prompt. Oh, I never doubted it for a second there, so I'll stop the tape, go into the monitor. Program counter is 65350. So that looks like it's checking. It's going to black the border, then it's going to load A with the H register, compare it with 1 and do a jump. So you can do a trace, which will do a single instruction. So it doesn't work with ROM addresses, but you can, so that we're going to do a compare with 1. Jump carry, so it's less than 1, so that's why the carry. Or A, so that's Z, so call if not Z, but so we're not going to do that. 65411 65, so load IY 23610. That looks, I like this. We're restoring basic because that's the value that IY is if for basic to work. So if I just disassemble 65329. So we're loading the IY value with the basic value. We're setting interrupts back to 1. We're doing a load HL with that value, which is the value that machine code routines return back to basic to say everything's okay. We're setting the R register to 0. We're loading the stack pointer to 24832, which is address, remember, from the map. That's the lowest bit of code that Speedlock loaded to. We're then going to enable interrupts, excuse me, and then we're going to do a jump to 36736, which I suspect is the game start code. So now we know that information, we can save the game code out to a file. So we've got that address. So if we do, there's a little simple calculator function. We do 65535, which is the highest address in memory. We do 24832. That gives us 40703 bytes. Then we can use the save memory command. Save memory 24832 40703, and then we do whiz.c. That'll go away and have a think, and it will hopefully save code, the game code to that file. There's a bit of a thing because it's to say it's not particularly fast. That's worked. Not particularly fast SD card. So we've got the code block, so we've got the screen. So we can just have a look at the screen with the $S command, and it'd be nice to get rid of that clock counter. So how are we going to do that? So if I press any key to get out of that, oh, I need to go back in actually. So turn off A, toggles the attributes, and then when you've got the attributes off, you can press G, and that will give you like a bright grid, which will so you can see the part where the graphics are. So if we see there, we've got the last character of the timer would be the 4th row, so that'd be 4 times 32, because each one of those squares is one scan line is 32 for the attributes, because we want to basically turn the attributes off for that section. So if I exit out of there, so we said use 3 times 32 is 96, and then we had the last row was 32 minus 6 is 26, so then 96 plus 26 is 122. And then the attribute bytes for the screen start at 22528. So if we do 22528 plus 122, that gives us the address 22650. So remember, we've got those 6 squares. If we poke those 6 addresses from 22650, 6 bytes, we can black those out, and that will remove the timer. So there's a fill memory command, so we can do fill memory. We want to fill it with 0, because that's ink 0, paper 0, which will be a black square. So let me do 23650, and we want to do that for 6. So then if we look in, that's done absolutely nothing. I suspect I've just randomly wrote over memory there with something. Let's try that again. I do fill memory 0. It's not 2 3s, it's 22650. Yes. So that's now got a nice clean screen. So if I can do save memory 16384 6912, which is the address for the screen in the Spectrum, then save that to $. Should hopefully save a bit faster. Do S. So we've now got a $.c and a $. So what can we do now? So if I do XX, that will exit the monitor. So we can knock ourselves up a little basic program. That's just some little tricks to avoid using numbers. So not pi is 0, it uses up less space than actually typing in a 0, because the way the Spectrum stores numbers, it stores it as the 0 that you see, and then there's I think it's like kind of a floating point value as well. So another trick we can do is you can just store your numbers as strings. So the 24832, so we do 24831. That clear will also clear the screen and do the border and the paper. And then we can do load star whiz dollar screen dollar, and then load star whiz 24832 and then randomize USR val 36736. Save star is ball. Seem to have hit inverse video there. Again. So we've got our Whiz Dollar, Whiz C and Whiz Ball. So fingers crossed, moment of truth. There we go. So eventually, after a bit of a faff about with the tapes and things and the monitor and me half remembering to do stuff and then remembering to do stuff, we've got a version of Whiz Ball which runs without Speedlock. So I'm sure you'd love to see me have an awful game of Whiz Ball, but I think this video has probably gone on long enough for that. So yeah, monitor's still being worked on, but it's nearer to being finished than it not being finished, if that makes sense. So hopefully I'll release a sort of a test version of that in the upcoming weeks. I may also do some more videos on it if there's any actual interest in it, because I imagine these might be about 5 people in the world who actually need this or be interested in this, because you could do most of this stuff with an emulator and you'd have a much better debugger. So hopefully I'm not going to get a content strike for the Whiz Ball music, because I've been talking over it. So best end the video there. Thanks for watching. I'll see you in the next video. Take care. Bye.